Yes, a disconnect is required before the automatic transfer switch when connecting a residential backup generator after the utility meter. This requirement ensures safety during maintenance, repairs, or emergencies by allowing complete isolation of the generator and transfer switch from both the utility and the home's electrical system. A disconnect switch provides a readily accessible means to cut off all power sources, which is crucial for protecting electricians, homeowners, and emergency responders. The disconnect should be clearly labeled to indicate its purpose and should be installed in an accessible location, typically near the generator or the transfer switch. The National Electrical Code, or NEC, mandates the installation of disconnects for generators in specific scenarios to enhance safety and facilitate proper electrical work. The specific requirements for disconnects can be found in Article 702 of the NEC, which pertains to optional standby systems, and Article 700, which addresses emergency systems. These articles outline the conditions under which disconnects are required, their ratings, and their placement. Firstly, the disconnect must be suitable for interrupting the available fault current at its installed location. This means the disconnect must have an interrupting rating sufficient to handle the maximum current that could flow during a short circuit or ground fault condition. To determine the available fault current, an electrician typically performs a fault current calculation, taking into account the utility source impedance, transformer size, and conductor characteristics. Secondly, the disconnect must be rated for the voltage and current of the generator system. This involves selecting a disconnect with an amperage rating equal to or greater than the generator's maximum output current. The voltage rating must also match or exceed the system voltage, such as 120/240 volts for typical residential service. Thirdly, the disconnect must be lockable in the open position. This feature allows electricians to securely de-energize the generator system and prevent accidental re-energization while work is being performed. Lockable disconnects enhance safety by ensuring that the circuit remains de-energized until the lock is removed. The location of the disconnect is also critical. The NEC generally requires that the disconnect be readily accessible, meaning it should be easily reached without having to climb over obstacles or use tools. The disconnect should also be located within sight of the generator or the transfer switch, or it should be capable of being locked in the open position. The purpose of this requirement is to ensure that anyone working on the system can quickly and easily de-energize it and verify that it is safe to work on. In a typical residential generator installation, the disconnect is often placed between the utility meter and the automatic transfer switch. This arrangement allows the entire generator system, including the transfer switch, to be isolated from the utility power. The disconnect can be a fused or non-fused disconnect switch, depending on the specific requirements of the installation and local codes. Fused disconnects provide additional overcurrent protection for the generator and transfer switch. The automatic transfer switch, or ATS, is a critical component of a backup generator system. It automatically switches the home's electrical load from the utility power to the generator power when a power outage occurs. The ATS monitors the utility voltage and, when it detects a loss of power, it starts the generator and transfers the load. When utility power is restored, the ATS switches the load back to the utility and shuts down the generator. There are two main types of automatic transfer switches. Firstly, open transition, and secondly, closed transition. Open transition ATS, also known as break before make switches, momentarily interrupt power to the load during the transfer process. Closed transition ATS, also known as make before break switches, briefly connect the generator and utility power in parallel during the transfer, avoiding any interruption of power to the load. The selection of the appropriate ATS depends on the specific requirements of the application and the sensitivity of the connected loads to power interruptions. The installation of a residential backup generator must comply with all applicable codes and regulations. This includes the NEC, as well as any local codes and ordinances. It is essential to obtain the necessary permits and inspections to ensure that the installation is safe and compliant. A qualified electrician should perform the installation to ensure that all requirements are met and that the generator system operates properly. In addition to the disconnect requirement, there are other important safety considerations for residential backup generator installations. Firstly, proper grounding is essential to prevent electrical shock hazards. The generator, transfer switch, and all associated equipment must be properly grounded in accordance with the NEC. Secondly, adequate ventilation is necessary to prevent the buildup of carbon monoxide, which is a deadly gas produced by generators. The generator should be located in a well-ventilated area, away from windows, doors, and other openings that could allow carbon monoxide to enter the home. Carbon monoxide detectors should be installed in the home to provide an early warning of dangerous levels of the gas. Thirdly, the generator should be protected from the elements to prevent damage and ensure reliable operation. The generator should be installed in a weatherproof enclosure or under a protective awning. The enclosure should be designed to prevent water, snow, and other debris from entering the generator. Regular maintenance is also essential for ensuring the reliable operation of a residential backup generator. This includes checking the oil level, changing the oil and filters, inspecting the spark plugs, and testing the generator under load. The generator should be exercised regularly, typically for about 30 minutes per month, to keep the engine lubricated and the components in good working order. A qualified technician should perform regular maintenance on the generator to ensure that it is operating safely and efficiently. The size of the generator should be carefully selected to match the electrical load of the home. An undersized generator may not be able to supply enough power to run all of the essential appliances and equipment, while an oversized generator may be less efficient and more expensive to operate. A load calculation should be performed to determine the total power requirements of the home, taking into account the starting watts and running watts of all appliances and equipment. The generator should be sized to provide sufficient power to meet the peak demand. The transfer switch must be compatible with the generator and the electrical system. The transfer switch should be rated for the voltage, current, and frequency of the generator and the utility power. It should also be listed by a recognized testing laboratory, such as Underwriters Laboratories or ETL, to ensure that it meets safety standards. The transfer switch should be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. The wiring between the generator, transfer switch, and electrical panel must be properly sized and installed. The wiring should be sized to carry the maximum current of the generator without overheating. The wiring should also be protected from physical damage and installed in accordance with the NEC. The connection should be tight and secure to prevent loose connections and arcing. The generator should be connected to a dedicated circuit breaker in the electrical panel. The circuit breaker should be sized to protect the generator and the wiring from overcurrent. The circuit breaker should be labeled to indicate that it is for the generator. The generator should be equipped with a low oil shutdown feature. This feature automatically shuts down the generator if the oil level drops too low, preventing damage to the engine. The low oil shutdown feature should be tested regularly to ensure that it is working properly. The generator should be equipped with a circuit breaker or fuse to protect it from overcurrent. The circuit breaker or fuse should be sized to protect the generator and the wiring from overcurrent. The circuit breaker or fuse should be tested regularly to ensure that it is working properly. The generator should be equipped with a voltage regulator to maintain a stable output voltage. The voltage regulator should be adjusted to provide the correct voltage for the connected appliances and equipment. The voltage regulator should be tested regularly to ensure that it is working properly. The generator should be equipped with a frequency regulator to maintain a stable output frequency. The frequency regulator should be adjusted to provide the correct frequency for the connected appliances and equipment. The frequency regulator should be tested regularly to ensure that it is working properly. The generator should be equipped with a muffler to reduce noise. The muffler should be properly installed and maintained to ensure that it is working effectively. The generator should be located in an area where the noise will not disturb neighbors. The generator should be equipped with a spark arrestor to prevent sparks from escaping and causing a fire. The spark arrestor should be properly installed and maintained to ensure that it is working effectively. The generator should be located away from flammable materials. The generator should be equipped with a fuel shut-off valve. The fuel shut-off valve should be used to shut off the fuel supply to the generator in case of an emergency. The fuel shut-off valve should be easily accessible and clearly labeled. The generator should be equipped with a battery charger to keep the battery charged. The battery charger should be properly installed and maintained to ensure that it is working effectively. The battery should be checked regularly to ensure that it is in good condition. The generator should be equipped with a maintenance schedule. The maintenance schedule should be followed to ensure that the generator is properly maintained. The maintenance schedule should include tasks such as changing the oil, changing the filters, and inspecting the spark plugs. The generator should be inspected regularly for any signs of damage or wear. Any damaged or worn parts should be replaced promptly. The generator should be operated in accordance with the manufacturer's instructions. The manufacturer's instructions should be followed carefully to ensure that the generator is operated safely and efficiently. The generator should be stored in a safe and dry place when it is not in use. The generator should be protected from the elements and from physical damage. The generator should be covered when it is not in use. The generator should be stored in a locked shed or garage to prevent theft. The generator should be operated only by qualified personnel. Qualified personnel should be trained in the proper operation and maintenance of the generator. Qualified personnel should be familiar with the safety precautions that must be followed when operating the generator. The generator should be used only for its intended purpose. The generator should not be used for any purpose other than to provide backup power. The generator should not be used to power equipment that is not designed to be powered by a generator. The generator should not be overloaded. The generator should not be operated at a voltage or a frequency that is different from the voltage or frequency of the connected equipment. The generator should not be operated in a hazardous environment. The generator should not be operated in an area where there is a risk of explosion or fire. The generator should not be operated in an area where there is a risk of exposure to hazardous materials. The generator should be turned off and disconnected from the power source before performing any maintenance or repairs. The generator should be allowed to cool down before performing any maintenance or repairs. The generator should be properly grounded before operating it. The grounding wire should be connected to a grounding rod that is driven into the ground. The grounding wire should be properly sized and insulated. The grounding wire should be inspected regularly for any signs of damage or wear. The generator should be protected from lightning. The generator should be equipped with a lightning arrestor. The lightning arrestor should be properly installed and maintained. The generator should be located away from trees and other tall objects that could attract lightning. The generator should be operated only in well-ventilated areas. The generator should not be operated in an enclosed space where carbon monoxide can build up. The generator should be equipped with a carbon monoxide detector. The carbon monoxide detector should be tested regularly to ensure that it is working properly. The generator should be refueled only in well-ventilated areas. The generator should not be refueled while it is running. The generator should be allowed to cool down before refueling it. The generator should be refueled with the proper type of fuel. The fuel should be stored in a safe and secure container. The fuel should be stored away from heat and flame. The fuel should be stored in a well-ventilated area. The generator should be inspected regularly for any leaks. Any leak should be repaired promptly. The generator should be kept clean and free of debris. The generator should be stored in a clean and dry place. The generator should be covered when it is not in use. The generator should be stored in a locked shed or garage to prevent theft. Proper generator disconnect installation practices are vital for safety and code adherence.